Hey guys, this video is for the last page of the study guide. Phosphoric acid is H3PO4, and it is one of the acids in Coca-Cola. KOH is a strong base called potassium hydroxide. Acids and bases react to form water and a salt. This is the essence of their neutralization. The acidic part of acid are the hydrogens, the basic part of base are the hydroxides. They combine to make water. HOH is water. However, because there are 3 acidic hydrogens on the phosphoric acid, you need 3 OH groups to neutralize. That's why we need 3 moles of potassium hydroxide, producing 3 neutral waters and 1 molecule of K3PO4 potassium phosphate. In a reaction like this, when you're given 2 starting amounts, you cannot automatically know from the mass relationships which are limiting. It's important to determine the limiting reagent so that you can predict how much product is formed. Notice that you have the same mass of each. Well, you cannot use mass to determine what is limiting because things do not react on a mass-to-mass ratio. As we've learned in class, they react on an atom-to-atom, molecule-to-molecule, or mole-to-mole ratio, not by mass. So this cannot be read 1 gram and 3 grams. It doesn't work that way. We must convert each of our masses, therefore, to moles before we compare. Using the molar mass of each substance, you can convert the potassium hydroxide and the phosphoric acid to moles. And when we do this, we see that there are 0.0357 moles of the acid and 0.0624 moles of the base. Now, the only time you could very quickly decide this was limiting because it's smaller would be as if it were a 1-to-1 chemical reaction. Unfortunately, it's not so easy in this case because 3 moles of potassium hydroxide are used for every 1 mole of acid. The potassium hydroxide is used up at 3 times the rate, or 3 times as quickly as the acid. That said, you have to take that into account before deciding one of these is limiting. By converting each to a product, you can then look and determine which is now smaller. Ms. Sessions has chosen to do that by saying, I'm going to look at how much water is formed. I did it in a slightly different way in class, and I'll explain that in a moment. So let's first take a look at how Ms. Sessions conceived of this. In essence, we're doing the same thing. She decided to pick one of the products. In this case, she decided to pick the water. And she picked water, although she could have picked K3PO4. You pick one, and what she did was she decided to answer the question, how much water would I make from each of these 2 starting places? If I use the H3PO4 as my starting, I get 0.107 moles of water made. And that's because there are 3 moles of water made for every 1 mole of acid, and 3 moles of water made for every 3 moles of base. When she uses the base, KOH, as her starting point, she gets 0.0624 moles of water made. Now, they cannot both be right. You get one or the other. And the correct answer has to be the smaller of these 2 numbers. Therefore, KOH must be the limiting reagent. It's very similar to the way I explained in class. The way I explained in class is I did not actually pick one of the products to compare. All we did in class was divide by, in this case, the numbers in front, or the coefficients in front. Notice that essentially she's doing the same thing. She's dividing the first scenario, the H3PO4, by 1, and the second by 3. You get the same conclusion that that KOH is the limiting reagent. She just took it and looked at it in a slightly different way. In either case, you must show your work, you must show or explain why you chose the limiting reagent you did. Simply picking one would not show to me, your teacher, or anyone else that you completely wrapped your mind around the concept and chose intentionally which one was limiting. The last question asks the mass of potassium hydroxide or phosphate that forms. Now, the mass of K3PO4 that forms is dependent on starting with the limiting reagent. Now, Ms. Sessions took the starting moles of KOH. If this number had been different than 0.0624, and had she chosen this as her starting spot, she would have made a mistake. The most important thing to realize is you want to use the starting moles of the KOH. It randomly turned out that these two numbers were the same. However, you always want to go back to the starting moles, not this answer to this calculation. When you start back at 0.0624 moles of KOH, 1 mole of K3PO4 is made for every 3 of KOH consumed, and then multiplying by the molar mass of K3PO4 gives you 4.42 grams of K3PO4. The mass of K3PO4 formed is therefore 4.42 grams. That was a typo. Sorry about that. I want you to fix that number. So in essence, one must determine which is limiting before moving forward in determining how much product you get. If this question also asked how much water was formed, again, you must start with the limiting reagent. That concludes this video series for your practice test. If you can do all the things on this test, you could look forward to an A on your actual test next week on Wednesday. I will be holding office hours Monday after school. Now, of course, everyone's getting out early on Monday, so the office hours time will not be at 3:05, but instead when everyone gets out of school. Okay? Have a great weekend.